Hello, everyone. Welcome to the first day of the second part of Chapter 8. This is 8.5, and today what we're going to start is our trigonometry unit. So I thought today would be a good day for a video because it's really a lot of definitions. So when we're talking about trigonometry, this goes with similar triangles and right triangles because when we know that we have a right triangle and we know one of the angles, we will know all those triangles with that angle are similar. That's how trigonometry works. Now, when we're talking about trigonometry, there's a couple important words. So in our right triangle, we know that the two sides that create the right angle are our legs, and the side across from the right angle is our hypotenuse. That never changes. When we're talking about trigonometry, though, we need to have a reference angle. So our reference angle can be either of the acute angles. So the reference angle is either acute. It is never the right angle. So if I say that B is my reference angle, I then have two other sides in addition, other labels for the sides in addition to the hypotenuse. So the hypotenuse, again, is always across from the right angle. The side next to angle B, our reference angle, is our adjacent. And the side across from our reference angle is our opposite. So we always have an adjacent leg and an opposite leg. So now for number 1, it says label appropriate sides as adjacent, opposite, and hypotenuse with respect to the given angle. So for number 1, my given angle is A. So our hypotenuse is always the side across from the right angle. That never changes. And then since A is our reference angle, that means AC is our adjacent side because that is the side next to it. And BC is the side across from our angle, so that is our opposite. Now, number 2, we're using the same triangle, but now my reference angle is angle B. So AB is still our hypotenuse because the hypotenuse never changes. It's always the side across from the right angle. But now, since our reference angle is B, BC is our adjacent, and AC is our opposite. So I want you to pause, and I want you to label triangle 3. Okay, so in 3, our marked angles are, so that means PR is our hypotenuse, because that's across from our right angle. QP is our opposite, because that's across from our reference angle. And QR is our adjacent. So who cares, Mrs. Van Steel? Why does this matter? Well, this matters because now we're going to start to talk about relationships. So again, we said that all triangles are similar if they are right triangles with the same reference angle. So now we're going to make sure that we can set up our ratio of adjacent and hypotenuse. So we're using these triangles up here, which we know are similar. So ABC is similar to A prime, B prime, C prime, and FED is similar to F prime, E prime, D prime. So an angle ABC, if angle A is 53, we're going to say that AC is 3, BC we need to figure out, and AB is 5. So to figure out BC, we're going to do the Pythagorean theorem, 3 squared plus x squared equals 5 squared. So that's 9 plus x squared equals 25. And subtract 9 from both sides, and we get x squared equals 16. So x equals 4. So BC equals 4. So now we want to do the opposite and over our hypotenuse. So A is our reference angle. So the opposite side is 4, and our hypotenuse is 5. So our opposite over hypotenuse is 4 over 5. Our adjacent side is 3 over 5. So now we're going to do the same thing for DEF, except for this time, I need to tell you which reference. Oh, I'm doing the marked angle. So angle F is our reference angle. And I know that my opposite over my hypotenuse is 12 over 13. So if F is our reference angle, our hypotenuse has to be 13 and DE has to be 12. So that tells me that DE equals 12, FE is 13. So now we need to find FD. So to find FD, I'm going to call that Y. I'm going to do the Pythagorean theorem. Y squared plus 12 squared equals 13 squared. So that's y squared plus 144 equals 169. Subtract 144. Y squared equals 25. So y equals 5. So DF is 5. So if DF is 5, that means our ratio is 5 over 13, which I'm going to make these decimals. 4/5 is 0.8, 3/5 is 0.6, 5 over 13 is 0.38. So now to get triangle ABC, we use a scale factor of 2. So if we use a scale factor of 2, does that change our angle? No, it doesn't. So that means our measure of angle A is 53. And if we're doing a scale factor of 2, that's going to double all their sides. Then for DEF, we're doing a scale factor of 1.5. So what I want you to do now is I want you to finish page 2 for homework. If you have any questions, we're going to pick up here tomorrow in class.